Okay. All right. Cool. So 5:40. Thank you very much for coming today. So this presentation is going to show a little bit of the concepts of using AI agents with Jupyter notebooks. And a lot of this is because I believe that we need to, in my opinion, figure out how do we expose data to an agent when it comes to data analysis. And obviously, some of this is very simple when it's just a demo data, just a couple of rows, a couple of tables. But when it comes to cybersecurity, those that have, actually, done investigations or incident response, there is a lot of data that you have to go through. Some of those initial steps usually is the data exploration steps. If you know what queries to run, usually it's very easy, right? To just directly try to find whatever it is that you are used to find. But in every investigation that I've been to, there is always data exploration that if we think about it, how we do it today with LLMs and AI agents is not as efficient as how we think it is, right? So we're gonna walk through the fundamentals and then start also using open source solutions and then showing you a couple demos. And also I'm releasing 2 projects today. There's like 3 Python packages that hopefully can help you to actually do your own research and using agents with Jupyter notebooks. And my name is Roberto Rodriguez. So I work for NVIDIA, but this talk I'm not on behalf of NVIDIA, right? So I'm not representing the company. This is usually my independent research work with the community. So a lot of the open source work that I do usually will happen outside of NVIDIA. So you can find me in LinkedIn and also in X or Twitter as Cyber War Dog. So all my research is and also GitHub is the same username. Now you're gonna see a couple of this actually during the talk, and I just wanted to do a quick 1 second. So this is I'm from Peru, so these animals represent multiple things. So you will see them around. So just to let you know, kind of share a little bit of the culture. But we're gonna go through trying to think about how to actually analyze data with AI agents, all the way to even showing you one basic use case, and then how we use also AI agents to be able, AI skills, sorry, to be able to structure that workflow and be able to enable a more structured autonomy in here. So thinking about how to reason about data with AI agents, right? So usually what you see on the left is what everybody else is doing, right? So everybody, whenever there is an MCP server that you get access to, either it is to expose a SQL database, Sentinel database, Splunk, you name it, every time we get access, all we do is we connect to it, and then we try to run a query, and then we expect all this data to be processed by an LLM. Usually, right, as I mentioned before, if you already know what you're looking for, you might not get a ton of data, but during an investigation, obviously, you're gonna get a ton. And having an LLM to actually process it for you is not the most efficient way to do it, right? They cannot do a lot of the fundamental, even data analysis techniques on their own. Most of the LLMs are not actually meant to do that, right? So you cannot pass thousands of JSON objects and then expect it to do a lot of the analysis for you, right? You will have to retrain a model, right? So in order to understand its structure, in order to process, right, the data in the right way. And then that part on the right is what I believe is the most interesting thing. This is not new. Actually, in 2024, there was some research about something called Code Act. And the basics is that rather than just passing data directly to an LLM, you could actually use some type of interface. It could be a sandbox. It could be a Jupyter notebook, a Docker container, where you process the data first before you pass it back to an LLM. So you are actually letting the LLM to use code to reason over the data versus trying just to reason over a ton of data by just consuming the text directly, right? So that's kind of like the super fundamental that we're trying to kind of show in here today. So this is what I meant before. In 2024, there was this technique that if you can see on the right a little bit, the idea is that when you ask a question, the answer will have to be figured out with code. So if there is a data set, either a file or just a bunch of data that you're being exposed to, the information is processed as code. So instead of actually doing one tool call per action that you want to take to process the data, you can actually just take one action and write a bunch of code, and the code is the one that is going to be orchestrating the reasoning so that the LLM actually gets the right information, right? So there is obviously benefits to this. As you could see, at least they both got to the same answer in here. This is from the paper. But the idea of being able to, iterate over the same concepts all over and over, the concept of using it as code, you can see the reduction of the number of interactions that it takes to process the information, right? And obviously, as you can see on the left, the code as an action did better across the other techniques. Now, what I'm going to show you today is a variation of this. It's kind of using this concept of how do I process data with code and not necessarily letting my LLM just to do a lot of these data analysis techniques, right? So what does that mean? For those that don't know about Jupyter Notebooks, so the 101 is that you are exposed to a browser, an interface that is backed by a Jupyter server that is going to expose a file, which is known as the Jupyter Notebook. And that file is a JSON file. And there is the concept of a kernel. And the kernel is what is going to host the execution of code, right? And the idea of why we use Jupyter Notebooks is because you're able to not only capture the state of every action that gets executed, right? So you can continuously, iteratively perform additional tasks, but at the same time, you capture your reasoning, right? You capture your reasoning, let's say, as markdown. You capture the code, the input, the output, right? Visualization. So it's a way to also audit, right? How something was, analyzed, right? So if I was a security analyst that is trying to also share my knowledge, right? How I did my analysis with somebody else, then I would, right, most likely share the Jupyter Notebook and organize it in a way that somebody else can actually use it as a playbook, right? So if you think about that, right, for us as humans, that's just nature, right? Just to kind of take notes, write some code, and then just share it with somebody else. We want to do the same thing with AI agents to be able to expose their reasoning in their whole process. So it's kind of combining the concept of code act, right, with some additional layers of, sharing and auditing the reasoning. So the way how it works, kind of like going a little bit deeper, as I mentioned before, the notebook kernel is what you will expose to an agent in order to give it that layer of execution that an agent can actually write some code. As I mentioned before, it can capture variables state, for example, so you can continue iterating over the data. And there are other techniques that have actually come up recently. There is one called recursive language models, and that one, for example, uses a similar technique. It uses a REPL type of approach to be able to also execute code, to be able to filter through several documents or several unstructured data, task over unstructured data for several documents, right? So that's also another technique that came up. So there is this evolution of using the LLM to drive the orchestration of the actions, and once again, not letting the LLM to be the one that is going to be processing all of this information. And a kernel has a shell channel, and then it also has an output channel. So the kernel itself needs to be hooked into that in order to take advantage of it, right? So now going a little bit deeper into what that means is if I want to now enable an agent, right, to use this whole ecosystem. So this is where the research kind of started to kind of go into, right? So what I did is I created this MCP server that has its own MCP tools, right, to be able to, for example, communicate with a kernel locally or remotely, be able to execute code, be able to also use a notebook interface in order to start creating new notebook cells, such as a markdown, a code cell, etc. And then I created a Python package which it's used by the MCP server. So instead of having everything in one place, I wanted to separate the actual implementation of communicating with kernels and with Jupyter notebooks, and then exposing that to the MCP server. And then, as I mentioned before, exposing these capabilities locally and also remotely, right? So from a kernel perspective, right, you can easily, with a Python client, like there is a Jupyter client Python package that you can use to be able to enable that execution layer locally. Or you could actually expose a Jupyter server that is going to be hosted somewhere, and you can communicate with that kernel to be able to access execution. And then the results of the execution of the kernel are going to be exposed through a Jupyter notebook, right? So that's what you see all the way at the end, a notebook session that is kind of like attaching the kernel with the notebook, and now we have access to that interface. But as you can see, the agent, all it knows is that it can simply add cells in the notebook and then execute the cells, right? And then obviously I added this session manager layer so that way I can open multiple sessions and multiple notebooks. And this is when you start getting into maybe autonomous systems that are creating multiple notebooks for multiple tasks, right? So this is the fundamentals of how we go from using the basics of a kernel of a notebook and then start kind of stitching that together with an AI agent. So this is what I have open source today. So there are two Python packages. That one on the top is the one that is going to be exposing all the wrappers around Python clients. And then the one at the bottom is simply the MCP server that has all of these capabilities to be able to interact with the Jupyter notebooks. So let's go to the next one. So there is this quick demo. Right here. So this is an example of how you can do it locally. So if you git clone the Jupyter toolkit, GitHub repo, right? You can actually see that there is an MCP JSON file that you can use. And this is VS Code. So in VS Code, you can use this file. And there is two ways to do it. You can actually run the server directly from the code that was downloaded. So that's what we're going to do here. And we're using just a fundamental stdio way to execute the server. And then we're just pointing to the package, right? And we have a couple of variables. One is saying we're going to run this locally. And two, we're going to expose a Jupyter notebook locally that is already open in VS Code. And then we can later show how we can use it as a server. But this is just the super fundamentals. Git clone, just enable the config, and then you should be able to start interacting with your Jupyter notebook. On the right, we have our chat. It's using Opus 4.6. And then if you Command-Shift-P, you can list all your servers in VS Code. You can find the server. You can start it. And you can see, obviously, the output when something is going to be starting or not, right? So I just opened that just to kind of show you how usually I will go about it. And then I simply start the server. And that automatically is connecting locally with the notebook. If it doesn't exist, it's going to create one. And then it just sets everything up, exposes the tools to the agent, and then we can use those tools. So as you can see, there was a notebook that was created. This is blank, like there is nothing in it. And this is just showing you that in VS Code, it's just a file that has a kernel locally running. So we can just say, use the notebook MCP server, and then create synthetic data, right? Just to kind of show the capabilities of doing this locally, right? And right away, it identifies that, well, first starts thinking, but then it's going to identify the tools that we have in place. It's going to check what notebooks are available. And obviously, it knows that there is a default notebook, so it's going to use it. And then automatically, the agent, all it knows is that it has to add markdown cells, start adding some code. And as you could see, the question was create a data frame and then visualize it. And instead of running multiple tool calls to maybe do that, if you expose tools that allow you to do it, it's just using directly one tool call and writing the code in order to be able to generate all of this information, right? So we went from not having interactions with a notebook and an agent with a simple config. We could actually see that the agent is actually using all the tools to be able to interact with it, right? So very simple. I mean, there's a lot of work obviously behind it, like the trying to figure out the kernel and the notebook and all of that definitely takes time. But what I was showing you here is that every single tool call, right, there is some input that's all the agent knows is just to write code or write markdown, and that's it. And then everything just gets executed locally, right? Oh, so then we can also do the one remotely. Same thing, we go back to our mcp.json file. We have the same setup. We're pointing to the local folders. And now we're going to comment out those local variables because we want to enable the server mode, right? So right now, and then obviously there is other variables that allows us to point to a remote Jupyter server right now. So we're going to stop this server. Once again, Command Shift P, and then you stop the server. And then, or you can do it also directly. So VS Code, recognizes that a server is there. So we can comment those variables. We enable the server mode, and right now we just say, you know what, I want to start with one notebook also, right? And then we're going to point to a local Jupyter server, right? It's just a Docker container, and then we set up a token that we can use to authenticate to it, right? Nothing crazy. It's just saying now we want a server, and here is what the server is. That's it. This repo comes with a Docker Compose file that shows you how you can set up a Jupyter server. And it also has a token variable that you can set in order to be aligned with the MCP server. And then, so we can simply go to that quick starts folder, right? Docker Compose up, and it's going to start the Jupyter server with a very basic server. And then at the bottom, you can see that we could actually now go to that server. We're going to make it bigger a little bit, and then also set the token that we set up. This is just like me trying to figure out that we have everything ready. And then you can see there is no notebooks yet, right? It's just empty. And now if we go back to the actual config once again, the MCP config, we need to start the server, right? Because it was stopped. And once we start it, if we go back to the actual server, we're going to see, well, first in the logs, you're going to see that there is communications with the Jupyter server from the MCP, and it's actually checking if there is a notebook created, and if it's not, it's going to create it for you. And then we can access this notebook just by double clicking on it. You can see there is also a one empty notebook, right? And we're going to put it to the side because we're about to put kind of like two windows together. So this is not a bug in my in my demo. So now that we have everything ready, right? The MCP is communicating. Now we can get our chat window, and we're going to by accident I closed it in there. We're going to open the window again, and then we're going to put it just next to the server, and then we can start same thing as before, just communicating, right? We want to once again be able to write some code, but one additional task that we're adding is show me your reasoning with markdown. Like I would like you to tell me what it is that you're about to do before you write some code. So now we add that rule that don't just write code, right? I want you to actually explain to me like what's going on. And this automatically is using the kernel session remotely on the Jupyter server, and it's automatically, it's going to start adding a couple of cells. Obviously, initially, all of these CLIs and IDEs are usually planning before they do something. But you can see that similar as the local demo is, reading the notebooks, is trying to open the notebooks that are by default. And then it's gonna check if packages are installed or not. So it knows that it needs to visualize things. It knows that it needs to use DataFrame. So it checks if pandas, matplotlib are actually installed. And then it just, now that it knows it's good to go, it starts just writing in a more structured way because I'm telling it to reason over with markdown. So this is, once again, super fundamentals. We're not showing anything revolutionary yet, but I think it's pretty cool to be able to see it in action, being able to, in a structured way, write some code, be able to summarize it, etc. Now, one thing that I'm going to say, that is happening also here is that whenever there is data that is exposed, for example, obviously, the LLM is reading that data frame that has like 20 rows, etc., right? But when we're going to take this to the next level, we're going to have to change that a little bit, right? We don't just want to say, if the data frame has 500 rows, I want you to read the data frame, because it defeats the purpose of the initial claim, right? That we shouldn't be just querying data and then give it all the data back, right? But so far, this is just kind of testing how the markdown and code execution is, right? And you can see how it's pretty good, right? It's pretty good at actually driving the reasoning and the task as code, right? So once again, with only a few clicks in the config and setting up your Jupyter server, you already have that capability with any IDE, right? This is VS Code with GitHub Copilot. You can do it with Cloud Code, with Cursor, Codex, right? CLI, etc. Right? Okay, so that kind of shows you the local and remote way to do this. So now we're going to take it to the next level. So now we need to connect our agents to actual data, right? So we have been just showing a basic demo. So what does it mean when we want to connect it to a database like a PostgreSQL, for example, right? To a Sentinel, Splunk, etc. Right? So this is what we had so far, okay? And just to recap, right? We're just exposing one layer to the agent, just a few tools, but behind the scenes there is all of these connections, using specific protocols, like WebSockets, for example, when the kernel is remotely, or using ZMQ protocol when it's local. And then when the Jupyter Notebook is also remote, we're actually using, you can see the document transport over there, right? You can see that we can use the Jupyter APIs because the Jupyter server comes with an API, so you can just hit it and then be able to create notebooks, delete notebooks, etc. But one thing that we actually use in here is the collaboration feature of Jupyter servers. So what does that mean? When you are connecting to a remote notebook, right, and you want the agent or something to be able to interact with it, right? I want to see what's going on in real time, and I would love to maybe also intervene and add a couple of things. You can only do that if you're using the collaboration feature of Jupyter servers. Usually, this is enabled by default in Jupyter Labs. So we use that capability to be able to interact with the notebook all the time. So in the future, you can have, right, potentially a combination maybe of collaborators, right, with this one notebook. It's very tricky right now, but it's possible in the future, right? So that's what is happening right now. So how do we extend this? Is this now? And here is when it starts getting a little bit tricky. Because now I want my agent to be able to feel like I'm communicating with the database through code, right? I would like it to feel like if I just say query this and run this query, I want it to be very easy for the agent just to interact with it. So what's going on in here? Before we only had kernel and notebook tools. Now we're adding a set of tools called the Postgres tools, right? This is just one module. And what is the Postgres tool? the Postgres tool is basically saying, I'm going to write new notebook cells, like code cells, and I'm going to use a Python package to be able to automatically connect to the database and be able to run some queries, right? That's kind of like the fundamental concept in here. So what does that mean? That means that all the way on the Jupyter Notebook session, on the kernel, for example, because the kernel is the one that maintains the execution, the imports, like every installed library, right, whatever that is, it's the kernel is the one that maintains that. So if I want my agent to interact with a database, and there is a Python client, like an SDK that can do that, I need to install that in the kernel and expose it to the Jupyter Notebook, right? So that's why you see the module being installed all the way there. But then for the agent itself, I'm going to show you right now, all I'm doing is just crafting a couple of code like a couple of code snippets to be able to support the concept of simply saying query data. Because it's not as simple as that, right? For those that are using Jupyter Notebooks right now, if you want to connect to something, you have to initialize a client, right? You need to authenticate. You need to test if the connection works or not. I don't want my agent to be able to spend time trying to figure out how do we connect, right? I just wanted to say query. And then underneath, the MCP tool is crafting that testing of the connection, connecting to the database, and then passes the query to the actual notebook cell, and then it gets executed. And in order for that to be executed, we need to have that Python package on the other side, right? So here's where it starts getting a little bit, once again, tricky, a little bit complex, but that's what it takes to be able to make it easy for an agent to interact with the database. So this is another tool that I'm releasing today. So this is the Agent Data Toolkit. And this toolkit, once again, is, let me see if I have it in here. Yeah, so for example, this is the repo. So the basic fundamental concept of this is that, as you can see on the left right here, we just have a bunch of wrappers around, PostgreSQL clients that allows us to connect and run queries and be able to efficiently interact with the server. That's all it is, right? So now we have this package that is going to be available in the notebooks, right? If I go back to my MCP server, which is this repo over here, right? And we go to the packages, we go to MCP Jupyter Notebook, source, tools, and we go to Postgres. I'm gonna hopefully can make this bigger, and I'll delete this, close this part. Let me just show you what one tool does. So there's one tool. Yeah, here it is. So for example, if the agent somehow wants to test a connection, right? Usually you will have to write code in order to test if you're connected to the PostgreSQL, right? So from the MCP side of the house, all we do is we actually write some code behind it, and we pretty much start testing it. So this, at the end of the day, so you can see the test query here by default. So we can actually run this for the agent, and all the agent needs to do is saying, can I just test the connection? But then there is code behind it that is doing all of that. So that's why you need to have a tool that is executing code on the notebook, and the notebook needs to be ready with all the Python packages to be able to run that code, right? This might be basic, but then once you start getting into, let me show you another one real quick. So you see the amount of code that, sorry, this one right here, my bad. This one, oh no, is query to DataFrame. There you go. So for example, this is a tool that what it does is saying, if you're an agent and you want to query something, just give me the query. That's it. Don't worry about anything else, right? and then I will execute it for you. And then whenever the results come back, I will summarize the results for you. I will gather some metadata from the data frame, and then I'll pass it to the LLM. But all the agent does is just simply says, I want to query something, and this is my query. That's it. So there is code behind this specific tool that it kind of, handles the execution and handles the output as well. So this is why there is a lot of, code behind it, right? So, all right. So that's kind of just giving you like a little bit of context, I guess, into what you can do with it. So we have this demo. So we're going to go back to the MCP server, and we're going to do the same thing as before, right? We have our server connection, our Jupyter notebook. We have our, right, it's pointing to a server, exactly how we were doing it before. Everything is working fine. We have the Jupyter server is ready. I refreshed it, so I delete everything, so that way everything is just new. And now this package comes with a new variable. Sorry, I think there you go. A new variable called like enable tools. So now this agent is not only right interacting with the notebook, it's right now also, as I mentioned before, now it has capabilities to connect to Postgres and interact with PostgreSQL, right? So I will add more modules later to be able to interact with multiple databases, right? And this is just kind of showing you what I was showing you before, right, in more details, because this can go a little bit fast. But the idea here is that instead of what everybody else is doing, which is just exposing you directly to a database with an MCP server, this is how do you say, like a more efficient way for an LLM or an AI agent to interact with databases with a lot of data, right? So this is just showing you the repo, and then we can just fast forward a little bit. So in here, I'm just, besides the Jupyter server, I'm enabling a PostgreSQL database with a very basic, there you go. There is a PostgreSQL also, container. And then in there is simply creating a database that it just has like 4 records, 5 records, right? But because this is just, I wanted to show that it is possible to interact with the database now, right? So if we go to the configurations, now you can configure also how you access this server, etc. So everything that the agent doesn't have to know, right? We have it ready there for the agent just to interact with it, right? So now we started this config for the MCP server. And if we check the tools that we have available now, we have notebook tools. And then if we scroll down in VS Code, now we have Postgres tools, right? And now you know that a tool has a lot of code behind it so that it's easier for the agent to simply worry about querying data. Don't worry about connecting, figure out if something failed or not from a connection perspective, because some of that could be very deterministic, right? We don't have to have an agent to try to figure that out. All right, so in here, we're extending the prompt a little bit. We're kind of saying we have specific tools now, and you can use it for data analysis. And then you're gonna see also that we kind of start structuring to how we want the agent to execute this. Like we want it to be able to understand that when you query something, you're gonna have a data frame behind. And it's doing it's doing the usual. It's trying to understand that there is a notebook in place, right? If the notebook doesn't exist, it's going to create it. And if we maybe we're gonna do playback, maybe do 125, so that way it's faster. There you go. So it's going to read the notebooks, and then it's going to start. As you could see, like it tries to connect, but all I'm doing is simply, right, kind of like showing it that we're good, right? Don't worry about that. So that's what it's kind of like, realizing that, all right, we're good. Like actually we tested that the client existed, but that was under the hood, right? And this is because the agent is going to try to act like, it's going to try to do what humans do, right? Checking the connections first. So we want to anticipate a lot of those actions, right? And then it's going to start, right, querying data. And I don't know if you notice here, so I'm going to probably pause it right here when it's trying to, one second. Oh yeah, there you go. So yeah, this is just trying to list the schemas. So it's kind of reading all the schemas that exist, and we anticipate a lot of these tools already. But then let me show you when it's querying something. I'll stop it. There you go. So you could see that all it did is I want to query this, and that's it, right? But if you look on the left, you can see that there is code in there, right? And that's because, once again, I just want the agent to worry about the query, and then the packages themselves will actually define and put together the right way to push a query, execute it, and once again, the output of all of this goes to a data frame, and then we are also gathering metadata of the data frame in order to pass it back to the LLM. And if we look at the output, we're going to see it right now in a second. And so, I don't know what. Okay, there you go. So in the output, you could see that we have a count of how many rows we have, or how many columns we have. We also have the schemas, right? The schema of that specific data frame. And then we also have a sample of the data that came back. So what does that mean? Right now, we only have 4 records, right? But the idea is that what happens when you query something and you get 500 records, 200 records, right? Custo query, for example, I think it's at 500 records you start getting, right? Like that's pretty much what you get, and then you have to do it again, but etc. Right? So when you do that for an LLM, for an agent, you don't want to just say go and figure out these 500 records. Oh, by the way, I forgot. Maybe I should do this, and then you continue giving it 500 records all the time to the LLM, right? That's not what we want to do. So the fundamentals in here is that if you're going to query something, okay, I'm just going to pass a summary of what the data frame is, and I'm going to pass a sample of the data frame. And then the agent itself already knows that there is a data frame in place with its own name, with its own metadata, and now it understands that it can actually use that data frame and maybe continue exploring the data frame, right? And then if it queries another probably data table, and then it brings another data frame, it can actually, using the Jupyter Notebook tools, it can actually see what variables are available, and then it could see that maybe I could join these 2 data frames, right? But a lot of that, once again, is being reasoned over, reasoned over with code, and not necessarily trying to capture 500 things here, 500 things here, 1,000 things, and it's trying to do a join behind the scenes. It doesn't work like that, right? LLMs don't do that by default, right? So that's the idea here, is one, to be able to expose it to very simple tools, right? And then at the same time, kind of help it, kind of help him to process some of these right tools that it uses, right? And then at the end, obviously, is, as you can see at the end, it actually summarizes whatever it learned from the data frame, right? So that's also part of this whole process in here. So that's what it means to go from interacting with a notebook to now connecting to a database, and some of the guardrails in place that exist that you could use to help the analysis, right, for the agent. And now let's dive into an actual use case, right? So this is so I was looking recently for a data set that was interesting to explore, and especially those that I haven't created, because I didn't want to have a bias to know exactly what to look for. And there's a YouTube video there of someone that does classes for the community. So you can go to that link in the GitHub repo. Also, I have like more information. And then you have the data set. The data set has like 4,000 rows, and it's just pure device logon events from Defender, right? Defender XDR. And then it's funny because in the video they ask questions about it, like about the specific data set, but the data set doesn't have the answers. It's kind of weird. So maybe that was just one of the samples that they wanted to share. But regardless, I wanted to figure out like what to do with this data. So the main concept of this is that there is some RDP access from external to an internal endpoint, and there is 4,000 events once again. And then, right, we just want to identify or explore, like, what's going on in here, right? What happened? Can we start even visualizing a lot of this information, right? So once again, good luck doing it with an LLM and with an NCP server. You're gonna see queries going back and forth multiple times, trying to like massage the data, read maybe the same data multiple times. It doesn't work, right? So we can test our approach of the code act and using code, I guess, or data analysis techniques, with Jupyter notebooks. So let's go to that. And I guess that's demo 4 right here. So in the repo, you're going to see that the repo has a demos folder, the agent agent Jupyter toolkit, and it has all the files that you need to be able to do this exercise, right? Shows you how to download the file. It shows you how to set everything up, and then obviously how to deploy the containers that will take that data set and will push it to a PostgreSQL. You can see this is an example of it. There's like 4,000 lines of data. And then, we do have the same thing, Jupyter server and a PostgreSQL. And then we have also SQL files that will process that data set and will create it and will ingest it, everything, right? So you don't have to figure out anything. All you have to do is download the data set and just run the code. Right? So I already run the Docker Compose. So my Postgres has the data, 4,000 records. My Jupyter server is enabled, and my MCP server is also set up. So my Jupyter server is enabled. Actually, let's check my MCP log. And I saw it was stopped. So I'm going to start that. But nothing changes. It's the same thing, right? We're just pointing to the git clone latest folder of the package. We're enabling a server, connecting it to it, and we're enabling PostgreSQL, right? That's it. So if you go to the README, there is a section where it kind of shows you the prompt, and you're going to see some rules in there, right? So we're going to have some rules for the agent to follow, and then we're going to have the context and what it is that we want to do with this data set, right? So, and then the objective, right? Like what it is that we want to do. And all of this is just exploratory, right? Like analysis, trying to figure out like what's going on with this. We do have some hints that there is a compromised endpoint and there is some external access over some remote protocol, desktop protocol, right? So we're going to copy that whole prompt. We're going to put it here, and then we're just going to, go with it, right? So the MCP starting created a new notebook, so now it's fresh. And then we simply, run this, and we can actually expedite it a little bit. So you can see that it already recognized the default notebook, right? So the same as before. And sorry. Oh, my bad. There you go. And so before I cut it, right, it was looking for the libraries to be installed first, and it just starts now going over the notebook, right? I'm going to fast forward this, play back. Oh yeah, so the first thing is that in some of the rules, I told it that it needs to be mindful that if you're going to be querying 4,000 things, maybe start trying to figure out something about the data set first before you go and try to query everything. This is a good example of recovery, for example. It failed at something, and it's so one of the good things about also doing things with code is that the debugging is easier because the code itself is going to show you a very rich error message. All of these libraries already have it, so it's pretty good for the agent to now read error messages from the code, and it's able to recover, delete the cells, and went back, and now it's trying to create new cells, right? It's trying to keep it clean, even though I didn't say delete cells that are bad. But one of the things that as this notebook is going to be created, we're going to fast forward a little bit. Just let me get to. You can see on the top, it says failure 61, successes 1. That was not created by the LLM. That was a result of code that provided that information. So that's what we're trying to get to. I don't want my LLM to count 61 rows and hopefully it tells me that there are 61 rows, right? I don't want that, right? I want to generate context with code, and I want the LLM to drive the code, right? So, this obviously, this presentation is recorded, so you could kind of see, and the notebooks are also can be generated, obviously, from the repo. So a lot of this information is just data that has been processed as code, and the LLM is just receiving that information directly, right? And if we fast forward more, we can see that it decided to visualize it now, right? And we're going to jump directly. It created a histogram, for example, which is cool. And so then, yeah, a heat map, not a histogram. A heat map, and then so now it's able to visualize that as well, and then it's able to now get to its conclusions. So now it says there is a critical finding here after going through all of this. There is one IP address that was actually involved. Let me see if I can probably stop it right there, because it's writing its conclusions. There you go. Stop it right there. So there is obviously one IP, right, successfully brute force. But what I like about this is that it didn't just query the database multiple times, right? It got to that conclusion because it was able to process the information in a way that will actually make it even more factual, right? Because the data is being analyzed as a data frame, as a visualization, right? So that was pretty cool because it was able to find patterns also. And a lot of the questions that were thrown to this data set before in the video, in the YouTube video and all of that, were very simple. We're just saying, find the IP that was externally communicating with something. But this whole analysis actually uncovered the whole simulation that whoever built this created, right? There were patterns that were created, and a lot of that was actually captured because the data was visualized, massaged, filtered, and everything as code, right? And that, to me, is fascinating because that's what I want to do, right? That's what I want. If I'm going to be processing data, I would love to be done this way instead of constantly giving an AI agent an MCP and just try to figure it out, right? And that's what a lot of people do today. Even security analysts, they're just exposed to an MCP and they just start writing queries, and they all of a sudden, after 15 to 20 minutes, they say, it's very slow now. And it's just hallucinating so much, right? This is one technique that complements. I'm not saying it will replace. It doesn't replace it. If you already know what to query, you're already doing a lot of this analysis yourself. But if you're exploring the data, I would do it this way, right? And obviously, the next step in here is how do we now, as you notice in the last prompt, I'm giving it a bunch of rules. And so I'm trying to structure, right, some of this analysis. And here is where AI agent skills kind of come into place. And now there is a way to start exposing all of this information of how I do data analysis to an agent, right? So for those that are not familiar with an AI agent skill, it's a document, skill.emd, that allows you to define a workflow for a specific task with a specific objective. And you keep that skill.md very light. You don't want to have 300 lines in there. I would keep it maybe 90 lines, 100 lines, maybe a little bit less. And then you write other documents that are considered references. You can see it on the right. And whenever those references are needed in the workflow, you then describe it and you say, I want, if you're about to query something, maybe you need to read best practices of querying data, right? If you want to visualize something, I would probably read best practices for visualizing data, right? So that's what, and all the way on the top of the skill, there is a YAML section, and that's the section that captures metadata of the skill itself. And that's the only data, I guess, that gets exposed to the LLM when the skill gets injected into the prompt, right? So what does that mean? You say you are the best data analysis ever, and then you could pretty much say, by the way, you have a skill that you can use to query data and use it whenever you're ready to do some exploration of data. That's all the LLM gets exposed to. And then when the LLM says, "Ooh, I want to use that skill," then the LLM is going to point to the skill.md file, the markdown, and it's going to start reading the file, right? And when it does that, as I mentioned before, this is an example how the prompt has all of these skills, all the metadata only, and whenever the conversation requires it, it's going to start reading it. And when it reads the skill and then a couple of other chat messages down the road, it starts reading guidelines and references. That's what is called progressive disclosure, because you're not exposing all the documents at once and say, now you're good. You're pretty much allowing the agent to only read what it needs at a time, and it keeps the context also manageable, right? So for example, if we enable that, right, we will be able to see all the way to the right. For example, before anything gets created in the notebook, you can see that it chose to actually read the skill before it performs the analysis. So now I don't have to have this long prompt with all my rules every time I interact with it. I just save it as a skill, and then I'm able to expose it to it, right? And I think that we have, oh yeah, I was gonna do that manually. So if I go to the agent Jupyter toolkit, right? So this, I'm gonna close this, so that way it's not a distraction there. The repo itself comes with a folder called skills, and this is a skill. Maybe I can probably, I don't know if there you go. So this skill is for data exploration. I have all the rules that I had before are in here, and then it starts going to understand the data set structure. If you want to query something, don't just go crazy and start querying, right? And if you do that, I want you to read this guideline. So then I go to references, go to the query guide, and then this query guide now starts talking about what are the query principles, right? So if you have a threat hunting team or an initial triage SOC analyst there, it would be interesting to start capturing, right, those like best practices or like core principles of your team, right? Every team is different. You might expose a specific knowledge for specific hunts, for example. So maybe you might want to have a skill that is very specific to some of these areas, right? So that's kind of like the idea. So there is also a data analysis, close this, close that, close that. There is also like a data analysis techniques where it goes over the specific types of techniques. Now, you could say the LLMs already know all of this. And yes, a lot of them already know, obviously, because they have a good understanding of the internet, right? So I'm pretty sure they have read a lot of data analysis techniques. But skills allows you to then kind of like a structure and say, we use these techniques when we do a hunt. We use these techniques when we do initial triage. So you're able to shape it a little bit and remind it that if you're working with maybe certain types of data, you can actually use specific techniques, right? So it's, once again, it's a way to structure autonomy, right? And then the same thing with visualizations, right? The types of visualizations that make sense to just remind the the LLM or the AI agent, right? So the way how you do this, so I'm going to do this live. So you go to the skills folder, you can copy this. So I'm gonna copy this folder. And if you are in VS Code with GitHub Copilot, there is already that GitHub folder that usually you add, like CI, CD pipelines and workflows. You can create a folder called skills, and then I'm gonna copy the skill over there, and that's it. So now my skill is part of my GitHub Copilot. And how do I test this? So I'm gonna open a new chat, and I'm gonna say hi. And then once it replies, right, you can go to the top to these three dots. You can open the debug view. We're gonna open this a little bit. All the way down, you see the hi message here. So I'm gonna go to the reply. And then this is kind of like the internals of the agent itself. And I can look for skills. And you can see that now my data exploration analysis skill and only this metadata, right, has been added to the prompt, and it already knows where the skill lives, right? So this now has been injected into the prompt. That's the way how it works for GitHub Copilot. That's a similar way how it works for other, CLIs and other IDEs, right? But that kind of gives you an example of just by copying that to that GitHub folder, restarting a chat, it already does that. Yes. The description, the name. Yes. Yes, exactly. Exactly. That's exactly what happens. Once it knows, so when you write a skill, you need to provide a what would trigger this skill, right? So in the description, you could say this is used for when the user wants to do X. And when the user wants to do X, it finds and it says, oh, you can use this, right? Yep. So that's how you do it. And now what we can do is, 1 second. I'm going to check my MCP, which is running. I'm going to check my server. I don't think it's running. Okay, so then I'm going to go to my terminal, and I'm gonna do this real quick. So tab Postgres. There you go. Okay. I need to be on packages, MCP, quick starts, and then I have. Let me see if I have. Okay, nothing is there. So I copy this. So all this is doing is just initializing my server. So I just wanted to make sure that we had everything there. You know what? Actually, I'll stop that because what I wanted to show you is with the big data set, not with a demo data, right? So what we do here is we go to demos and sorry. So demos, Postgres, and then we have, there you go, the Docker compose file. So if I go to demos, readme, and I copy these commands right here, this one, for example, that should start everything. Okay, so I was able to start again the big data set and all of that. And I'm going to, instead of copying the whole, I remember oh, there you go. And sorry. And so instead of copying these whole rules and all of that I was doing, I'm just gonna copy this last section, which is the actual thing that I want to do. And I just remember that if I go to my MCP right now, I can restart it. So if I restart my MCP, it's gonna try to refresh the connection to the Jupyter notebook server, for example, and it created a new notebook for me, right? So that's pretty much what I refreshed it because I want to have something that I know is fresh and clean, right? Okay, so now I'm going to expose my window there. And I could, so let's see if it picks it up. Like it actually picked it up before, like the skill. Maybe I need to trigger it by saying, the things of, we're going to perform a structure data analysis of a data set. No, of data in our PostgreSQL. Something like that. And some context, right? So I, disregarded the rules, right, section. And there you go. So it read my skill. It's also reading my MCP because the file is open, but it read my skill over there. So it was able to capture exactly how we would like to go over that. You can see that it's checking my references, for example, right? So it knows that it needs to check the data query guide, for example. So you see now how we gave it some structure and following best practices that we follow, right? And then after doing that, then it's going to start now trying to figure out how to interact with this tool, right? And so it's going to do the same thing as before, but I wanted to show you how the skills was super important now to be able to give it some structure, right? And we're going to go back to the slides because that was pretty much the last demo. We're going to get back to it once I finish this one. But the closing thoughts in here is that obviously this is not going to replace complete, obviously, data analysis that everybody does today. I know that some people might be getting triggered maybe later in, once they watch this video saying like, I can write all my queries myself. Yes, if you know what to query with your favorite query language, that's awesome. But I've been in a lot of investigations and that usually doesn't work that way. You have to do that data exploration. You have to connect the dots and you have to be ready with some type of autonomous system if you want to do it faster as well, right? So what is the AI-based approach to do it? This is the way that I would do it with notebooks and also like AI agents. And at the end of the day, we want to enable this iterative process of using code to analyze data. As I showed you before, instead of making a count, I would just want to use Python to count it, right? And then at the end, we want to provide skills to give it a structure, right? Best practices. So now the AI agent becomes one of us, right? It becomes one of our team members that understands how we actually do data analysis as a threat hunter or like SOC analyst, etc. And obviously, at the end of the day, the notebook becomes the audit item, artifact that you can use to understand the reasoning behind it, and then you can turn those into playbooks, right? If we go back here, for example, after speaking for a few minutes, I could see that it is actually doing what the skill said to do, understand the structure, right? So now it's understanding the structure first before it tries to run things, etc. So you kind of get the idea that this is a more structured, even way to share this reasoning with somebody in my team, right? You can find all of this in the CyberWar GitHub repo, all the packages, all these exercises. And if you are using open code, for example, or using local models, you can download this, get the repos, and if you have to fly out back home, you can just just enable this and like do it in the plane, right? You can just have your Jupyter notebook going through 4,000 lines of rows of or JSON objects and try yourself. So thank you very much for your time, and I hope you enjoyed this talk. And that's it. Thank you. And I guess we don't have time for questions.